So, first step in correctly predicting the products of a chemical reaction is to identify the type of reaction that is occurring. Okay, because then we know the pattern that will produce the products. Okay, so in question number 5 here, I have beryllium, which is a metal, as an element, okay, reacting with iodine, which is an element. What kind of reaction starts that way? Synthesis reaction. Okay, so what happens in a synthesis reaction? They combine and form a single compound. All right, so we're going to have Be with I. Now, what kind of compound did I just make? What do I have to do with all ionic compounds? Swap and drop. Okay, so iodine's a -1, beryllium's a +2, so this will be BeI2, and that makes the whole equation already balanced, so we're good. Okay, everybody all right with that? Okay, what about number 6? I have an element in potassium reacting with iron 2 oxide. Single replacement reaction. Okay, in a single replacement reaction, the lone element will replace the part of the ionic compound that it is like. All right, so potassium is going to replace who? Iron, right? It's going to replace iron because potassium is a metal and iron is a metal. All right, so iron's going to end up alone and potassium is going to end up with oxygen. All right, what are some things I have to check for? Special elements. Is iron special? No. Okay, it doesn't come as a 2 or a 4 or an 8, so I can leave it like that. And I have an ionic compound that needs to be dropped and swapped. Okay, so this is a -2, this is a +1, so we got K2O. All right, and then we got we have to balance that. Okay, so we got 2 potassium over here. Looks like everything else is good. All right, suddenly feeling like I did that yesterday. And nobody said. I said, hey, how many people have done 5 and 6? And everyone says, me. No one says, because you did them yesterday. Thanks. Okay, good question. I don't know if we answered that yesterday or not. Does it matter whether iron goes first or the K2O goes first? The answer is no, it doesn't, as long as they're both there. Okay. The only thing that does matter in terms of order is if you're making an ionic compound, metal has to come first, non-metal second. So in other words, I wouldn't have written Fe plus O K2, right? I have to write it as a proper ionic compound. And I think I showed you guys the trick I like to play yesterday. Yeah, okay. So, all right. Okay, how many people are done number 7? Because I know I didn't get to that one. Okay, let's, we'll wait on that. Do you get a question? Yes, we can do number 10 eventually. Yes. All right. So I'll give you another minute or 2, and then I'll go over 7, and we'll look at the rest here. Okay, let's have a look at number 10. Okay, because we didn't get that one done yesterday. So we got lead 4 chloride. Okay, and I know that this lead has a 4+ charge just because chlorine has a -1 charge, so there has to be lead 4. Okay, and then I've got cobalt 2 phosphate. Okay. And I'm assuming it's cobalt 2, but I'm going to double check. Okay, so phosphorus is a -3. Okay, so I have a total of 6 negative charges, so I need 6 positive. So yes, okay, this is cobalt 2, right, when I'm doing my reaction here. All right, so now when I make the products, I'm just going to swap the metals because it's a double replacement reaction. So that means lead's new partner is phosphate. Cobalt's new partner is chlorine. Okay, since they're both ionic compounds, they both have to be swapped and dropped. And that's why I went back to figure out what the charge on lead was going to be and what the charge on cobalt was going to be, because I knew I was going to have to drop and swap my products over here. All right, so we said lead's the 4+, phosphate's 3-, so we're just going to drop and swap. Okay, so we're going to have 4 and 3, okay, as our numbers there. And then, okay, we're going to have cobalt, it's the +2, okay, chlorine's the -1, so we're going to have CoCl2. Okay, generally we start with what's present in the largest number. That could be chlorine or phosphate. Okay, doesn't really matter which one we go with. I'm going to go with phosphate, just because I got a feeling about it. Okay, so I got 4 phosphate over here. I only have 2 over here. So what do I need to put here? Okay, how many cobalt does that give me? All right, so I'm going to go over here and make sure I have 6 cobalts. That gives me 12 chlorines. All right, so what do I need to put in front of this? All right, I like how this is working out. okay? Because that 3 leads matches up with the 3 leads I have right here, okay? And now everything should be balanced. All right, everybody follow there? Okay. So what I want to work on today, guys, is just practicing this stuff, okay? So you have a couple of reaction worksheets that are prediction based, okay? So we're going to move on. Okay, so 6 and 7 are probably not, I probably wouldn't give you ones like that on a test, okay? But they're just to make you think a little bit. They're a little bit trickier to balance, okay? And then the rest are all prediction problems, right? The key is part of the key package I posted on Friday's post in Google Classroom. So if you go back to that post, the key for this is also in that package. What does it mean to the atoms?
Yeah, like so let's say that you have like KCl2.
Right.
Like, what does it mean when you're actually putting this or like that? Why do you see?
Okay, so let's just look at one of these here as an example then. Okay. So let's say we're working on number 4 here. Okay. So when I have the 3 Na, when I have Na3N over here, if I only have 1 molecule of that, that means I have 3 sodium atoms and 1 nitrogen atom, right? If I want to balance it though, okay, on this side I had 2 nitrogen atoms. Over here I only have 1. So in order to make that work, I have to put a 2 here that is saying I now have 2 molecules of this stuff, right? So I'm changing both the number of molecules and as a result, the number of atoms. Okay, so now, I'm not changing this molecule, I'm just changing how much I have of it, right? Because when you balance a reaction, like we've been kind of speaking kind of simply and saying this is the number of molecules. In reality, this could be the number of moles, or it could be a ratio of mass. It's just a factor. It's a coefficient, right? It's just simply, it's more simple to vision it as it's 2 elements or 2 molecules or 2 atoms. Does that sort of answer your question? Okay. All right, so let's go working on that there, guys, and then I'll go over any ones that give us trouble. Okay. Okay, so I've got the 2 OHs here, and now I've made 2 over here. Now, this H that's attached to the OH had to come from ammonium, because ammonia over here is short one. Follow me there? All right, so if I took this H from over here and I need 2 of them, I need 2 of these in order to make that work, right? That means I'm also going to need 2 of those. Okay, so now if I'm looking at this, I've got 2 nitrogens on both sides. I've got 8 hydrogens. 2 times 3 is 6, and 2 more is 8. 2 hydroxides, and 2 hydroxides. 2 chlorines, 2 chlorines, and 1 calcium. Yeah, the ammonia broke up in this reaction, right? I didn't break it up. It broke up. Right. If an ion breaks up, then you have to balance it piecemeal, right? You got to go element by element, and that's what I did here. I started out, well, I didn't really go element by element, but I went hydroxide is here, and I know I need 2 of them. And then I went, okay, where did this hydrogen come from? Well, if there's only 3 hydrogens attached to N now, that means the other one came from it over here. And then I just made sure I had enough of them to account for what I did with the water. And then I started balancing the other parts that would be thrown off. Okay, so I need 2 nitrogens now. All right, that makes everything work from there. All right, those ones are quite a bit more challenging, but they still follow the same general pattern. Yeah. The next one is quite similar, actually. Okay, because again, the ammonium, breaks up over here, right? And again, the hydrogen, the extra hydrogen here, ends up with water, right? So if I've got 2 of them here, I probably need 2 and 2, right? At least to start with. Okay. Then I've got 1 sulfate, 2 sodiums. Okay, so that's perfect because that makes my hydroxides balance now. Okay, it also makes my sodiums balance, and looks like everything else is good. Right. How did I come up with which 2? Okay, this NH4 is in brackets and has a 2 beside it. that means there's 2 NH4s. So that means there's 2 nitrogens and 8 hydrogens. With me there? Okay, so I put a 2 in front of the nitrogen on this side to make sure I had 2 nitrogens on this side. Yeah? When I did that, that gave me 6 hydrogens here. And then I needed another 2 here to make 8. Okay, and when I did that, it gave me the 2 hydroxides I needed over here. Oftentimes we overthink it. Yeah. Okay. And like I said, those were a challenge, right? I just put those up there to, if you were starting to get cocky about how good you were about balancing equations, this would take you down a peg. You know? In the end, guys, it's an exercise to challenge you, right? Everyone needs it. You need a challenge once in a while, right? I mean, if you play golf and you always play from the white tees, you're never going to get any better until you play the blacks, right? Like you just gotta move around. You gotta try harder stuff. Okay. Okay, so we've got iron 2 sulfide. Okay, so iron with sulfide. Sulfide's a -2, and they tell me that iron's a +2. So it's FeS. And it reacts with oxygen gas, which is a special element, so I need to write it as O2, even though they told me that. Okay, what kind of a reaction has an ionic compound and an element? Single replacement. So we got a single replacement reaction, but our element here is a non-metal. So what part of FeS is it going to replace? The S, right? It's got to replace the non-metal. So that means I'm going to have iron end up with oxygen and sulfur end up by itself. Okay. Now, whenever we produce an ionic compound, we have to check that it's dropped and swapped. This is still iron 2 plus because it was iron 2 plus on the other side. This is 2 minus, so that compound is fine. But sulfur is an 8. It's one of our special elements. Okay. Now I got to go back and balance, right? So I got 8 sulfurs. So I'm going to put an 8 there to balance my sulfurs. I have to put an 8 here to make my irons work out. And when I do that, I've got 8 oxygens. So I need a 4 here to make the oxygen work. Okay, so it's just a matter, guys, of being able to recognize those reaction patterns when you encounter one. In any single replacement reaction, whatever is alone replaces what it is like. Okay, so you have an ionic compound as a metal and a non-metal. If this is a non-metal, it replaces the non-metal. If it's a metal, it replaces the metal. Yes. I would probably not give you one like that, but yes. Just like that? Yeah. Like I said, I just wouldn't do that, and I did. Yeah. Yeah. Hydrogen gas, when it's by itself, typically acts as a metal. Yep. That's not a charge. Okay. Don't confuse the fact that nitrogen bonds with itself in this way with its charge. Those are two different things. Nitrogen as an element bonds with itself and makes a pair. When it's in an ionic compound, it has a charge of -3 for the drop and swap. Yeah. Write it 2 when it's by itself. In a compound, it might have any number depending on how the swap and drop worked out. Okay. All right, so if I have calcium added to water, I'm going to have Ca, okay, added to water. And I'm going to write water as an ionic compound, right? Because the only way that this is reacting with something is if it's in a single replacement reaction. Or, right, because it's reacting with a compound. So we have to write water ionically. Now I can write Ca would end up with OH, and hydrogen would end up by itself. Okay, we could also write it this way. Okay, it would actually be correct to write it either way. Okay, I could write it like this. I could write it that way too. And in fact, both of those things happen when calcium reacts with water. Okay. Not with calcium, no. Sodium, yes. What do you mean? Yeah, no, yeah, in terms of the way I wrote it the first time or this way, no, they're both right because in actuality, they both occur. Yeah. Yeah, and I think on the key I have both, don't I? I thought on the key I had both written there. Maybe I don't, but yeah, either one is fine. All right, so let's have a look at number 6 here, guys. So we got molybdenum, okay, and molybdenum's got a charge of, well, it says it's 6 there, right? Okay, so, yeah. All right, so molybdenum oxide. Okay, this is a -2, this is a +6. When I drop and swap, I'm going to get 2 and 6. Can I reduce that? Yes, to 1 and 3. All right, it's going to react with hydrogen gas, and when hydrogen gas is by itself, it acts as a metal. Okay, so hydrogen is going to switch places with which part of this? With the molybdenum. All right, so that means that molybdenum is going to end up by itself, okay, and hydrogen is going to end up with oxygen. And it usually does so like that. Okay, you can write it as HOH if you want as well. Okay, but in this case, it makes more sense to write it as H2O so I can follow where I got the oxygens from. All right, now I've got to balance everything. Right now, everything except oxygen is balanced. So I've got to go over here and get myself 3 oxygens. When I do that, it gives me 6 hydrogens, and my molybdenums are still 1 and 1.
How do you know if to switch the hydrogen with metal or?
Because when hydrogen is by itself, it acts as a metal, which is one of those things we got to remember. Yeah. 4? Yep. Okay, so I got magnesium nitride. Okay, and it's mixed with water. Now, first thing I got to do is drop and swap this. Okay, this is Mg3N2. All right, and it's going to react with water. I'm going to write water as HOH this time. Okay, so hydrogen here acting as the metal is going to switch places with magnesium, right? Okay, so I'm going to end up with hydrogen and nitrogen being together, and magnesium and oxygen being together. Or sorry, magnesium and hydroxide being together. All right. These are both ionic compounds, so I got to drop and swap them. This is a -3 and a +1, so H3N. Okay, this is a +2 and a -1. So like that. Okay, those are my products. I just swap the metals. When I want to balance this thing, okay, I'm thinking I probably want to start with magnesium. Okay, and I'm going to make 3 magnesiums over here, which will give me 6 hydroxides. I'm going to go back over here and make 6 hydroxides. That makes 6 hydrogen. Putting a 2 here fixes the hydrogen problem, gives me 2 nitrogens, and there's 2 on the other side. And now I'm good. Okay. You could have also written this one, if you wrote it as H2O, it would have been Mg3N2 plus H2O, okay? And then you might have had your products look like this. Still H3N, but you would have had MgO, okay? And that's fine. You can still balance it, okay? You still need a 2 here and a 3 here and then a 3 here, and it'll work, okay? Either way would be correct, okay? Depending on the way you wrote water. All right, any other ones? How are we feeling about this? Are we feeling reasonably confident? Okay, we're still going to be working on this for another day or two. Okay, but yeah, we're going to get good at it before we move on to the mole. That's the last thing, by the way. I was just looking actually at the calendar to look at when our unit exam is going to be, and unfortunately, right when we'll be done the unit is right around the Thanksgiving weekend. So I think I'll be pushing it too hard to make it happen on the 5th. So I'm gonna probably start the next unit on the Friday, teach the next unit on the Tuesday, and have you guys write your unit exam on October 11th. Okay, that's 3 weeks from now, even though we might be done the unit before that. Okay, but that gives you lots of notice as to when the unit exam is, lots of time to practice, lots of time to come in and get help if you need it. Okay, all of that kind of stuff. I will be giving you a unit exam review package probably that first week of October. Okay, so you can take that home and start working on it. And it'll have sample questions. It has some old unit exam multiple choice, some old unit exam short answer kind of questions so you can get an idea of how I ask things. Okay. All right, so let's look at number 10 here. 10 is using the rare form of copper, the copper with the +1 charge. Okay, so we have copper 1 sulfide. Okay, now sulfur is a -2, copper is a +1. Okay, so when I do the drop and swap, I'm going to be Cu2S in this case. Okay, and it's reacting with oxygen gas. Oxygen's a special element, so we have to have a 2 there. Right, that's going to form. Okay, and this time it actually gave it to you. It didn't even make you predict it, right? Because the actual products are there. Okay, to form copper 1 oxide, which will be Cu2O, because this is a -2 and this is a +1. Okay, and sulfur dioxide, and that's the reason why I gave you the products. There was no way for you to predict that this is what was going to happen. Okay, in this reaction.
Do you tell the special elements you only the things under?
Yes. Okay, that's their elemental form. In a compound, they can have any number, depending on either a prefix or dropping and swapping. Okay, so that number only applies when they are in their elemental form. We highlighted them on your periodic table, and we used a color code. Yeah? Okay, so now when I got to balance this thing, my coppers are balanced. See, it's 2 on both sides. I got 1 sulfur, but here's the problem. I got 3 oxygens on one side and 2 on the other. Okay, so I've got kind of an odd even type of problem here. Okay, so what I'm going to do is I want to get rid of this odd number. The best way to get rid of an odd number is to double it. Okay, when I double it, now I have 4 oxygens on this side. Now I can go back over to here, okay, and start looking at what I have. So if I put that 2 there, okay, that gives me 4 coppers. So I'm going to put, whoops, no, not a 4, a 2, not a 4, a 2 here. Okay, that gives me 2 sulfurs. So I'm going to go back over here. I have to make sure I have 2 sulfurs. Now that just made more oxygen, but still an even number of oxygens. All right, so 2 oxygens here and 4 more here for a total of 6. Now I have 6. Okay, so if you ever run into that problem where you kind of got the odd even thing going on, the best way to fix it is to double the odd number. Okay, that's why we do that in the combustion reactions. Okay, we double it so that we don't get an odd number of oxygens on the other side. Right? I did. This is copper 1, +1 and -2. No, only in the name. Yeah, we don't write Roman numerals in the formula. From the formula, we can tell because of the numbers which charge it was. We only write it in the name because in the name we can't tell. Yeah. 13, yeah. All right, so we got barium chloride, so BaCl. This is a +2 and this is a -1, so this should be BaCl2. Reacts with ammonium carbonate. All right, so that's ammonium, it's a polyatomic ion, and so is carbonate. Okay, this is a +1, and this is a -2. Okay, so we got to drop and swap. So when we do this here, the 1 will go to the carbonate, the 2 will come to the ammonium, so I've got to bracket the ammonium and put a 2 beside it for my swap and drop. Okay, so now I've got my reactants. What kind of reaction is this? It's a double replacement. Ammonium, because it's positively charged, behaves like a metal. All right. So I'm going to swap the metals. That means barium is going to end up with carbonate, and ammonium is going to end up with chlorine. Okay. This is a -1, this is a +1, so dropped and swapped, that one's okay the way I've written it. This is a +2, this is a -2, so dropped and swapped, that one's okay the way I've written it. Everybody follow so far? Yeah? All right, so now I've got to balance the whole thing. Well, there's 2 chlorines on this side, now there's 2 chlorines on that side, and that gives me 2 ammoniums. There's 2 ammoniums, and now I'm done. Okay, so the trick there is when you have ammonium, you have to realize it behaves as a metal, because it's a positively charged ion. Okay. Any other ones giving us trouble there, guys? You guys are doing pretty good. I didn't really expect this to get quite that far, so that's good. All right, keep her going then. Okay, so let's look at 14 here first. So we got iron 2 chloride. All right, so that's going to be Fe, that's got the 2 plus, with chlorine, that's 1 minus, so FeCl2 is reacting with sodium phosphate, that's Na with PO4. That's a -3, this is a +1, so we're going to have Na3PO4. All right, so those two things are reacting. They're both ionic compounds, so what kind of reaction is this? Double replacement. All right, in a double replacement reaction, we're going to swap the metals. So Na is going to end up with chlorine, and iron is going to end up with phosphate. Since they're both ionic, I need to check their drop and swap to make sure that they're okay. This one's a +1, this one's a -1, so that one's fine. This one's a +2, this one's a -3, so we got to change some numbers. We're going to need a 3 here, we're going to need brackets, and a 2 here. All right, what's my next step? Balance the whole reaction. What should I start with? Well, if I start with sodium, I'm going to be erasing that number. Here's how I know why. Sodium's a +1. Iron's a +2. It's a +2 charge. So it's got the same number that sodium has, which means it's going to have a bigger effect on my balancing numbers than sodium does. So I'm going to start with iron. That's just a little trick you gain with experience. Okay, I'm going to start with iron. There's 3 over here. Okay, so I'm going to put a 3 over here. That's going to give me 6 chlorines. So I'm going to go back over here and make 6 chlorines. Now, when I put a 2 here to give myself 6 sodiums, that's going to make my phosphates work out. Had I just put a 3 here, okay, a 3 here, I would have been erasing it and starting over again. All right, everybody follow? Not that that's the end of the world. It's just you wouldn't have got very far starting with sodium, okay, on that one. Okay, and then 15 was the other one? Okay, so 15 we got zinc oxide. Okay, zinc is a +2 and oxygen is a -1, so it should be ZNO. Reacts with hydrogen chloride. Okay, both are ionic, so what kind of reaction is it? It's a double replacement. All right, we swap the metals. Who's the metal in this one? Hydrogen. Okay, so hydrogen is going to end up with oxygen, and zinc is going to end up with chlorine. All right. -2 + 1. Can I write that as that? Yep, I can write it that way. Oxygen was not part of OH over here, so I can do it that way. Okay, it makes sense. You could write it as HOH2 if you wanted. Okay, and then for this one here, I got +2, -1, so I'm going to have ZnCl2 there. Right? Had I written this as HOH, it wouldn't change anything. Right? I'm still going to balance it the same way. All right, so I've got 2 chlorines and 2 hydrogens on that side, so a 2 here pretty much fixes everything. Okay, and it wouldn't be any different if I had written this as HOH. These 2 hydrogens had to come from here, right? Because only oxygen came from the zinc. All right, any others? 16? Okay, so copper 2 sulfate, so that's the 2+ copper. Sulfate's a -2, so we're good, written that way, CuSO4. It's reacting with iron solid, that's Fe. What kind of reaction is that going to be? Single replacement, okay? And since iron is a metal, who is it replacing? It's going to replace copper. All right, so copper is going to end up by itself. Iron's going to end up with sulfate. All right. They did not tell me what charge iron has in this reaction because there's no way to know when iron's an element, it has no charge. So what do I go with? The most common, which is 2. All right, so then this is a 2+, this is a 2-. It's fine the way it's written. The reaction is already balanced. 3 is first? Oh, okay, sorry, 3 is first. Yeah, you're right. Okay, so this is -2. So we got a 2 here, sorry, and a 3 here. All right, so now we got to rebalance our equation. I'm going to start with the sulfates, even though it really doesn't matter what order I do it in on this one. Okay, and the 3 there will make everything work. Sorry, yeah, you're right. 3+ is the most common. Okay. All right, so tomorrow I'm going to have a couple more examples that we'll kind of walk through together. And then Monday, we're going to be working on a little project that you'll have 2 classes to work on. That'll be coming due probably about 2 weeks after that or so. Okay, remember the date of the unit exam is now set. I will not move it. Okay, it'll be October 11th because, well, we'll be done this unit before that for sure. Okay, and that gives you plenty of notice and plenty of time to come and seek help and all that kind of good stuff.